This speech is my recital. I think it's very vital to rock around. That's right.
On time.
It's tricky. It's the tight. Here we go. It's tricky to rock around. To rock around. That's right. On time. It's tricky.
Hello everyone. My name is Jason Harworth and this is my ENME351 final project. So what I made was basically an auto tightening system for a snowboard binding. And the way the system works is that there's 4 load cells underneath the binding which sense if there's any weight on the binding pushing down. And if weight is sensed, the user can then push a button to start the auto tightening process, which is on this breadboard. And then when the button is pushed and weight is sensed, this servo opens the binding right here at this point. It pulls down on the binding and opens it to allow for the DC motor to wrap up the binding and tighten the binding. So we now have the code running and the processing output shows how much weight is currently on the binding, which is basically 0. And in the top left, I don't know if you can read it, but it says preparing to tighten, and that just kind of tells the user that there's no weight on the binding and there's also no user input saying that it wants to be tightened. And that user input would be if the button was pushed. So if I push the button now, it changes from preparing to tighten to not enough weight detected, which just means that you have to put a weight on for the button to work. So now when we put a weight on here, which is this approximately 5.5 pound jar of coins, the processing screen turns to green and says that it's ready to tighten, which means that if you push the button, it'll start tightening because there's enough weight detected to tell the motors to turn on. So now if I push the button, it'll tighten. You can see it's wrapping up and tightening the binding. And then when you turn it off, it holds the position because the binding is now closed as opposed to open when it was tightening.